Everyone, this is a problem from a Japanese competition. It's quite challenging, so we have to solve it. Let's take a look. It says x to the power of x equals 3 to the power of open parenthesis, x plus 243 close parenthesis. Find the value of x, everyone. When you see a problem like this, do you feel stumped at first? Can x be 0? X equals 0 doesn't seem to work. What about 1? 1 doesn't work either. Is it 1 to the power of 1? How about 2? 2 doesn't work either. This isn't easy to guess. So, what should we do? Notice that both the base and the exponent involve x. You must think of the isomorphism method. What is the isomorphism method? Suppose x to the power of x equals a to the power of a. Then I can conclude that x equals a, because the exponents are the same, right? We want to achieve this isomorphism, so how do we do that? Let's simplify it a bit. The left side is still x to the power of x. As for the right side, can't I write it as 3 to the power of x times? Times what? Times 3 to the 243rd power. Everyone, according to the fundamental theorem of exponents, when you multiply, you add the exponents. So when you multiply these two, the exponents add up, right? Okay, so what do we do next? Shouldn't I move this x over to one side? If I divide both sides by 3 to the x, doesn't that work? So it equals 3 to the 243rd power, right? Right? Now the x is isolated on one side, isn't it? And if I put the x exponent up there, doesn't it become open parenthesis x over 3 close parenthesis to the x power? Isn't that right? No problem, right? It's equal to 3 to the 243rd power. That's fine, right? Okay, so how do we achieve this isomorphism? The base here is x over 3, and this is x. Can I make this x also become x over 3? So if I take both sides to the 1/3 power at the same time, and you all also take this side to the 1/3 power, doesn't that achieve the isomorphism? Look, what does the left side become? X over 3 to the 1/3 times x. Isn't that just x over 3 to the x power? Any issues? What about the right side? 3 to the 1/3 times 243. That's 81, right? Yeah, it's to the 81st power. Everyone, you need to be careful when solving problems. So what do we do next? X over 3 to the x over 3 power equals 3 to the 81st power. So how do I achieve this isomorphism? That is, making some number to the power of some number equal to another number to the power of another number. So what should I do? Just break down this 81. 81 can be written as 3 times 27, right? Right? Of course, you can also write it as 9 times 9 equals 81, or you can write it as 9 times 9. You can also write it as 3 times 27. So obviously, it should be written this way. 3 to the 3rd power is 27, right? Right? So doesn't that mean it's equal to r equals what? 27 to the 27th power, everyone? This is the fundamental theorem of arithmetic. It's 27 to the 27th power, 3 to the power of x, raised to the 3 to the power of x equals x, 7.2 to the 7th power. So 3 to the power of x must be 27. What is x? 3 times 7 is 21. Isn't it 81? If you don't believe it, substitute x equals 81 back in. Verify if it's correct. You really need to learn this problem-solving method, everyone.